In this lesson, we're going to review the volume of prisms and cylinders. I will remind you that a prism is a three-dimensional figure whose base is a polygon. So you've got some examples here. A triangular prism, of course, would have a base which is a triangle. A rectangular prism has a base which is a rectangle. A cube has a base which is a square. A pentagonal prism would have a base that is a pentagon, and a hexagonal prism would have a base that is a hexagon. The side across from that one, of course, is the matching polygon, and all of the other faces of a prism are rectangles. Now, the reason that we group a cylinder in with the prisms in terms of the volume lesson is because a cylinder is similar in the sense that the base is a circle, which isn't a polygon exactly, but across from that circle there is another matching circle, and the way that we find the volume for a cylinder is quite similar to finding the volume of a prism. So that's why we've grouped those shapes together, and you'll see what I mean momentarily. So let's have a look at our first example, which is to find the volume of this triangular prism. Now, when we're finding the volume of a prism, there is one sort of formula that works for them all, and you've got that right here in your note. To find the volume of a prism, as well as a cylinder, incidentally, we take the area of the base and we multiply it by the height. I've said height / depth because depending on which way your prism is oriented, it doesn't always make sense to say the height. So for example, in this particular example that we're looking at first, the base of this prism is a triangle. Even though that's not the side that your shape is sitting on, that is still considered to be the base. Okay, because remember, all of the other faces of a prism are rectangles. So the triangles have to be, okay, one of those triangles has to be the base, and it doesn't really matter which one. So that's why I've said in your volume formula that we're multiplying by the height or the depth, because in this case I think it makes a little more sense to consider this side here to be the depth. Okay, so we're going to take the area of the base, in this case the base is a triangle. Okay, so we're going to take the area of that base. Now the area formula for a triangle is base times height divided by 2. And we're going to multiply that by the depth of this figure. Alright, so looking at that triangle, the base is 4 and the height is 6. Divided by 2. And the depth of this shape is 8. So now we'll simplify that. 24 over 2 times 8, so 12 times 8, so we've got a volume of 96 centimeters cubed. Moving on to the next one. Now we have a cylinder. And the cylinder has a radius of 3.5 centimeters and a height of 7 centimeters. Now remember, finding the volume of a cylinder is exactly the same as finding the volume of a prism, in that we are going to find the area of the base, multiply it by the height. In this case, the base is a circle, and the area of a circle is pi r squared, and then we're going to multiply that by the height. Okay, so that's how we develop the volume formula for a cylinder. Pi r squared h, the area of the base times the height. Now we just have to sub in our radius and height. So pi times 3.5 squared times 7. And if you type that into your calculator, you should get 269.4 centimeters cubed. Okay, next we have a word problem. It says a hockey puck has a diameter of 3 inches and a height of 1 inch. A cylindrical container holds a stack of 4 pucks. What is the minimum volume of this container to the nearest cubic centimeter? Now, when you see this type of wording in these questions where it says what is the minimum volume, don't let that confuse you. All that really means is that in this container there would be no extra space. Okay, so try to picture a container that would hold 4 pucks exactly. Let's see if we can create a sketch with no extra space between the pucks and the container. Okay, so that's what they mean by the minimum volume. So if we had a stack of 4 pucks, we know that the diameter is 3 inches. Let me fix that. There we go. And we know that the height of each puck is 1 inch. So altogether, the height of the stack of 4 would be 4 inches. Now, one other thing to note here in this question is that it asks for the volume to the nearest cubic centimeter, even though the dimensions are given in inches. So this is where, if you remember from previous lessons, I was telling you to make your life a little bit easier, we're going to convert the dimensions to centimeters first. Okay, and remember that 1 inch is equal to 2.54 centimeters. So using that conversion, 3 inches would be 3 times 2.54 centimeters, so 7.62 centimeters. And 4 inches would be 4 times 2.54 centimeters, so 10.16 centimeters. So if you convert those dimensions to centimeters first, then when you find the volume, your answer will be in cubic centimeters already. Okay? An alternative would be to find the volume in cubic inches and then convert it at the end. That's just a little bit trickier. So I think that this is an easier solution. Okay, so now we can find the volume using the same volume formula we used in the last example. Volume of a cylinder, pi r squared h. And now we just have to remember that the diameter is 7.62. So I guess we have one other little piece of work to do here. We have to find the radius, which would be half of the diameter. Which would be 3.81. And then we put that into our formula. Which is approximately 463 centimeters cubed. And that concludes this lesson.